Hey everybody, Mrs. Bianchi. We're looking at question number 3. Sally has 8 red marbles and 16 green marbles. She also has red bags and green bags. She wants to put marbles in the bags that match their color. Each bag will have the same number of marbles. What is the largest number of marbles she can put into each bag? In class, we talked about how there are words that you should look for that might help you to understand what you need to do. One of the things that we're asking you to look for is the idea of greatest number of, which is the same thing as largest number of. When you see that, generally you're dealing with GCF. Now, if you have to use distributive property with GCF, then the other words that I'm asking you to look for are the same number of, same number of. Now, when you see both of those things, it's a good idea to see how many question marks are in the problem. Is there one question mark or are there two question marks? I'm just seeing the one. So if we look at the question again, the question is, what is the largest number of marbles she can put into each bag? And remember, when we think of GCF, you want to think of something per something. So we're talking about marbles per bag. So I'm just going to put an M for marbles and a B for bag. Marbles per bag. Now, since it's not asking for the number of bags that might be red and it's not asking for the number of bags that might be green, it could have asked for that. It could have asked for the total number of bags that are being used. It didn't ask for that. So we're talking about red bags and we're talking about green bags, right? Didn't ask for that. So really, quite frankly, all they're asking for is this. So you could press on and do this, but then you're really wasting your time. It wouldn't be a complete waste of time because you could check your work and see if the numbers that you get add up to be the same thing as if you were to add the 8 and the 16. So in that regard, maybe it's not a waste of time. But basically, all we're doing for this question is we're finding the GCF of 8 and 16. Now, you want to ask yourself, is the smaller number a factor of the greater number? And if it is, then the smaller number would be the GCF. But if that doesn't make sense to you, then you're going to go ahead and proceed with your factor trees. And when you're done with your prime factorization, I want to remind you that you put the common factors where the circles interlock. So your prime factorization for 8 will go in this circle. Your prime factorization for 16 will go in this circle. And anything they have in common, you'll put them in here and multiply them together, and that will be your GCF.